And screen share. Oh, I didn't turn my camera on. Try it again. Okay, so while we're waiting, I think I can finish up the rest of the section, which is 1.3, and I'm getting there. Okay, so it looks like I'm about a day ahead. My original goal was to finish 1.3 by tomorrow. I think I'll finish it today. So much the better in case something goes wrong again. We'll see how it goes. Okay. All right. Oh yeah. One other thing I got to talk about in terms of typing stuff in the chat. So I'm going to have to stop share so I can get back to the chat. Okay. For some of the in-class assignments that you're typing out, okay, it's hard to type some symbols in the chat. So I'll go ahead and show you how to do stuff. So just bear with me. I'm going to put stuff in the chat. So let's say you want to write something squared. Okay, so you use the up caret. So everybody look at the chat. That's how you would write x squared, or x cubed would be like this. Okay, square root, you type sqrt. Okay, so square root. Okay. Obviously, when you type on a keyboard, you can't get all the symbols as nice as normal. Plus, minus, times, and divide are usual. So, you know, plus, minus. For multiplication, it's the asterisk above the 8, capital 8, and the slash is division. Okay, so that's plus, minus, times, and divide. Let's see, what else? So you use the up caret. Up caret is the capital above the 6. So if you look at most keyboards above the 6. So I've shown you how to have x squared, x cubed. Square root is usually squirts. Parentheses are usual. There are parentheses on your keyboard, right? So if you have to do something like 3 minus 4x in parentheses or whatever, that would be 3 minus 4x. Okay, so you might need that for today's in-class assignment. You might have to type squares or cubes or square roots, and so those are some abbreviations. Those are all I can think of right now. Well, the trig ones, you can just type sine, cosine, tangent, as usual. We'll do natural log, ln. We'll do maybe log, but we'll worry about it when we get to it. But I think the ones that I've typed right now, those are the ones that you may need for today. Yeah, in terms of how do you type it on the keyboard and so forth. Okay, so just wanted to let you know that. And now let's go back to where we were, if I can get there. Okay. All right, so last time I got up to, I think I'm done with 9 through 23. So I'm going to try to knock off the rest, 29 to 41, 52, 53. Okay. Again, in case you're wondering, most of the problems I'm doing are right off the homework. So that's one less problem you have to do. Just go back and review it. Okay. And again, when it comes time for the test, which is on Friday, February the 5th, okay, the coverage is chapter 1. What are you responsible for? Everything here, right? What do I turn in for homework? All of this. When do I turn it in? The day of the test. I don't need it day by day. I don't even need it week by week. You turn all of this in on the day of the test. So just take pictures on your cell phone. Just, you've got written it out. You know, you've got, I don't know, 3, 4, 5 pages. Just click, click, click. Or if you have a scanner, scan it, and then just email it to me. Okay? And then same thing for the test. I will send you the test via Canvas announcements. Just write on a piece of paper. So you, when you're finished, you got 2 or 3 pages, whatever. Just same thing. Click, 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 and email it to me. All right? That's the way it works. Okay, so I'm going to try to do 29 to 41, 52, 53, and then give you the in-class assignment. Okay, I already did 29. 31 is really not that big a deal. I'll just talk about it. Okay, so please look at 31. Sorry, I can't point it to you because I'm holding up the book. Okay, you have 2 functions. F of x is x cubed plus 2x squared. G of x is 3x squared minus 1. All you're doing in A, B, C, and D is add, subtract, multiply, and divide the functions. Okay. So to add the functions, just add them up. Okay. In fact, maybe I can do it in my head now. The sum would be x cubed plus 2x squared plus 3x squared would be 5x squared, right? Minus 1. So the answer to A is x cubed plus 5x squared minus 1. You just add them, right? And B is almost just as easy. The only thing to watch out for B is that you have to think of the whole thing as being in parentheses. So for subtraction, for 31, B, make it parentheses. Sorry, I can't write it. Parentheses, the first one, x cubed plus 2x squared. Put that in parentheses. And then minus parentheses, 3x squared minus 1. Otherwise, you'll get it wrong. Okay, so one more time for B, put parentheses around x cubed x cubed plus 2x squared, parentheses, and then minus parentheses, 3x squared minus 1, which means you have to distribute the negative. C, FG means multiply. So it looks like it's going to be FOIL, right? So you go parentheses, x cubed plus 2x squared times, which means you don't have to put any symbol, and then parentheses 3x squared minus 1. So just FOIL it out, right? D is the easiest of all, F divided by G. So just write a fraction, right? And then on the top, just put x cubed plus 2x squared, and in the bottom, put 3x squared minus 1. That's pretty much all you have to do for 31. Okay, the domains, well, let's see, since they're polynomials, A, B, and C are going to be all real numbers. I showed you how to do all real numbers, just write that funny looking R. Okay, I'll be doing that from time to time more, but the funny looking R. So when you add, subtract, and multiply polynomials, you get back a polynomial. So that's all real numbers. The only one that's a little bit tricky is D, F divided by G. That's going to be a limited domain. So I'll let you think about that. The denominator is going to be 3x squared minus 1, right? And you know that's not allowed to be 0. So to solve D's domain, set 3x squared minus 1 equal to 0. So you get x equals blah, 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 and throw that out. So again, the best way to write that domain is all real numbers minus, put a minus sign, and then the set consisting of whatever. Okay, so look back at your notes on how that's done. Okay, so that's my hint for 31. All right, now 33, 35, and 37 are composition of functions, okay? See how it has F circle G, G circle F, F circle F, G circle G, and their domains. Okay, so 33, 35, and 37. So let's see, I think I was going to do 35 for you. So if I do 35, that'll hopefully help you to do 33 and 37. Okay, so composition of functions, F of G, G of F, F of F, G of G. You remember doing stuff like that in pre-calc, hopefully? Okay, so here we go. Okay, so this is composition of functions. Okay, again, ignore any dates that I have here. So when it looks like fog, F circle G of X, it means F of G of X. You do a function and then you immediately do another function. It's a function of a function, so to speak. Okay. So the functions they give us in the book are f of x equals radical x plus 1, g of x equals 4x minus 3. Okay, I'm going to start off with C and D for a reason. I'm going to go back for A and B. Okay, F circle F. So the function is radical x plus 1. So f of f means f of x. Okay, so what's all this f stuff? I'm getting dizzy looking at all the f's. Well, just don't even look at everything. So you're supposed to do the innermost first, right? So right behind my pen is f of x. Can you guess what happens in the next step? I can try to cover that. Okay, so I copy this outside f, the left paren and the right paren, but inside, instead of writing f of x, I write what it's equal to. What is f of x equal to? Radical x plus 1. Okay, and I know you've already seen it, but now let me cover this up. Okay. So now this thing, whatever's behind my finger here, goes right there. Okay, stop and think easy. If behind my pen was 5, you put a 5 right there, right? If behind my pen was W, you would put W plus 1. So whatever's behind my pen goes right there. So what is behind my pen? That. So it's going to be a square root of that, square root of x plus 1 plus 1. Okay. It's a little bit tricky. Right? But if you stop and think about the general idea, whatever's behind my pen goes behind my finger. Right? If behind my pen was a nice number like 3, then I put a 3 here. If it's a mess, I put the mess. So that's it. Square root of x plus 1 plus 1. And in case you're wondering, no, you can't simplify that. So just leave it alone. Okay, G circle G. So G of x. So the function is 4x plus 3. So G of x. So the next step, I leave this outside G alone. I leave the left and right paren alone. Okay, you're supposed to do the innermost. And now instead of writing G of x, I write down what it's equal to. What is it equal to? 4x plus 3. And now again, maybe I'll cover it up. So same game. Whatever's behind my finger goes right there, be it easy or hard. If it's a number like 7, I put a 7 there. So it's 4 times something minus 3. So there's the template. Look down here. It's 4 times whatever's behind my pen minus 3. So whatever's behind my finger matches whatever's behind the pen, right? If my finger has 25, then this pen, I'm going to put 25, right? 4 times 25 minus 3. If behind this finger is W, you would put 4W minus 3. If behind my finger is a mess, 4x minus 3, I put that mess right over here. So there it is. 4 times 4x minus 3 minus 3. And then I clean it up. You're all good at algebra because you're taking calculus. I don't think it's too hard for you to see what I did here. It's 16x minus 12 minus 3. So I said, okay, I don't have to write minus 12 minus 3. I can go straight to minus 15. Okay. If you were my Algebra 1 class, I would not make that jump. But you're in calculus. You can see, hopefully, oh yeah, 16x minus 12 minus 3, minus 12 minus 3 is minus 15. All right, the domain of this function is all real numbers. There's no trouble there. So there's that funny looking R for all real numbers. Okay. Yes, I know I didn't tackle the domain here. I'll come back to it. Okay. Now, fog, F circle G. That means F of G of X. Okay. So same thing. The next step, don't put G of X, write what it's equal to. So what is G of X equal to? 4x minus 3. So I put 4x minus 3 right here. And now this thing, be it easy or difficult, whatever's behind my finger goes right back up here. What is it? 4x minus 3. So 4x minus 3 goes right here. Okay. See, F parentheses. We like it if it's a nice number, right? So suppose behind my pen was 12, right? Then you would just put a 12 right there. So whatever's inside the parentheses goes right there. What is behind the parentheses? 4x minus 3. Okay, then I add 1, radical 4x minus 2. Yes, I know I have to talk about the domain, but I'll get to that later. Okay, or maybe I'll let you try to figure it out after I show you some others. Okay, G circle F means G of F of X. So same thing. Copy this G, copy the left paren, right paren, right? You got to do the innermost first. So don't touch that. There's a G. Leave the left and right parentheses alone. Now, the next step, what is F of X? Radical x plus 1. So I put radical x plus 1 there. And now again, whatever's behind my finger goes into the G function. It's 4 times finger minus 3. 4 times whatever's behind my finger minus 3. So there we go. So that's how that works. All right, now I'll go back and tackle some of the domains. So I've done C, D, A, and B in kind of a strange order. But let's talk about the domain now. So A. So A was radical 4x minus 2. Okay, so you know that has to be greater than or equal to 0. Right, anytime it's the square root of anything, right? Greater than or equal to 0. Okay, so that's pretty easy. Add 2, divide 4. That's 1/2. X is greater than 1/2 greater than or equal to half. So the domain is bracket 1/2 to infinity. Okay, and then let me get D out of the way because, sorry, B. Yeah, B should be pretty easy. This is what I have, right? So the only trouble spot is a square root. So again, since I have a square root, the thing behind my finger has to be greater than or equal to 0. X plus 1 greater than or equal to 0. Subtract 1. X is greater than or equal to 1. So the domain is bracket -1 infinity. Make it a little bit higher for focusing purposes. Okay, so remember, bracket means include the -1. Parenthesis means don't include the endpoint. Infinity and negative infinity always use parentheses. Okay, now for the harder one, F circle F. How do I find a domain of this crazy thing? You got a square root inside a square root. Okay, so for something like this, you can tackle each square root separately. Okay, so we get a square root inside a square root. So first of all, if I only look at that thing, right, radical x plus 1, for sure that has to be greater than or equal to 0. Right? So again, I have to have at least x greater than or equal to -1. So I can't plug in like -2. Okay. And then on top of that, it's a square root of a whole mess. So again, I'll cover it up with my finger. So I see square root, blah, blah, blah. So whatever is behind my finger also has to be greater than or equal to 0. Right? So there it is. Radical x plus 1 greater than or equal to 0. I'll raise it up for focusing. Subtract 1. Square root x plus 1 greater than or equal to -1. Okay. But wait a minute, if you take the square root of anything, it's automatically greater than or equal to -1. So that's always true whenever x is greater than or equal to -1. Okay, so in other words, the domain is also bracket -1 to infinity for that one. All right, so that's what I have for that one. Okay, so I just did 35 in its entirety. You do 33 and 37 on your own. Okay, and then let's see, 39 and 41. Find F circle G circle H. So you have a composition of 3 functions. Okay, so I'll show you one of those. So 39 and 41. I'll do one. I'll let you try the other one, I guess. Okay, so it looks like I did 39. F circle G circle H. Yeah. And then all we have left are 52 and 53. Then I'll be done with the section pretty much. Okay, so here are the 3 functions from the text. F of x is 3x minus 2. G of x is sine x. H of x is x squared. Let me raise it up again. Again, anytime I raise it up, I can't hold it that long. All right, F circle G circle H. It means F of G of H of x. Okay, now if you start to get dizzy and say, man, there's too much stuff here, I can't get that. Well, like I often say, if you don't like looking at everything, don't look at it. We just did this kind of stuff, right? G of H of x. And even before that, just say, okay, can you at least get past H of x? Once you get past H of x, go to G of H of x. Well, that's just like the stuff we did over here, right? So that'll give me some expression. And then once I get that expression, I'm going back to F. Okay, so remember you got all these parentheses. Oh man, I'm dizzy with all the parentheses. Go to innermost first. Okay, so focus just on H of x. Never mind about that F, that paren, that G. Okay, just look at H of x. So in other words, by order of operations, when you see parentheses inside parentheses, you do the innermost first. So I'm just going to copy the F, paren, G, paren, paren, paren. Okay, I'm supposed to do H of x anyway, right? So leave that alone, leave that alone. The next step, I'm going to change H of x to what it's equal to. What is H of x equal to? X squared. So guess what I'm going to have behind my finger? X squared. So I'm going to have F of G of x squared. Okay. So now I do that. Okay. Again, you might say, well, that's too much stuff. I don't like looking at it. Well, what am I supposed to do next anyway? G of x squared. Then don't even look at this, right? Forget the f stuff. Right? I'm getting too dizzy looking at all the parentheses and all that. I do get dizzy too. Don't even look at it. Just say g of x squared. Say, okay, that's just sort of like the stuff I did over here. G of x squared. So what is g sine x? Okay. So suppose it said g of pi. I put a pi right there. Suppose it says g of pi over 6. I put pi over 6 right here. So what do you think g of x squared is? Sine of x squared. And leave it like that. A side note, in case you're wondering, is that the same as sine squared of x? No, it isn't. Okay. Sine of x squared means the sine of x times x. If you put the 2 here, sine squared x, like in trig, right? That means sine x times sine x. They're not necessarily the same. In fact, usually they're not the same. Okay, so when it's written like this is the sine of x squared, sine of x times x. That means if you give me the angle, right? Like, I don't know, pi over 4, you square the angle first and then take the sine. That's not the same thing as saying sine squared of pi over 4. That means you take the sine of pi over 4 first and then you square it. Okay, so it's order of operations. Okay, now I apply this mess to f. See, I don't like to look at it. Don't look at it. Just say whatever's behind my finger goes right here. Start easy. Suppose my finger had 1. Wouldn't you put a 1 right there? Right? Or behind my finger was 3 million. Put 3 million right there. All right? Or behind my finger is a mess. What goes right there? The mess in parentheses. Okay? So there's the mess. 3 sine x squared minus 2. But then you stop and think about it. Well, I don't really need the parentheses. So 3 sine x squared minus 2, final answer. Okay. All right, then all I have left are 52 and 53, which are pictures from the book. So I have to show you the book. Unfortunately, I can't write and hold the book at the same time. Now, if we were meeting on campus, okay, I could project, just the middle of the board, the text, and then I've got whiteboards on either side where I can write it. Since I can't do that now, you just have to write down as I talk. Unfortunately, that's part of the disadvantage of, the way we're meeting right now. But be that as it may. Okay, so 52 and 53. So unfortunately, I can't write it for you. You'll have to pay attention and write it on your own. Okay, am I willing to do the whole thing? Yeah, I guess so. Okay, this book is really heavy. Maybe I'll try to go like this. Sorry, if it looks crooked, it's because I got the book down on the table and I'm kind of angling it up so it's not so heavy. So it looks distorted. Maybe that's a little bit better. Okay, use the table to evaluate each expression. Okay, that shouldn't be too bad. You got x, 1, 2, 3, 4, 5, 6. Then f of x, 3, 1, 4, 2, 2, 5. And g of x, 6, 3, 2, 1, 2, 3. Okay, so it goes inside out. Okay, so if you look at E and F, G circle F of 3, that's the same as G of F of 3. And likewise for letter F, F circle G of 6, that's F of G of 6. So you're supposed to do the inside first. Okay, the inside first. Okay, yeah, if you show this to me on homework, quiz, or test, there's not much work except you might want to do the inside part. Okay, so in other words, just show me what this is. And sorry, I can't write it, but you get the idea. Okay, so first start with G of 1. What is G of 1? G of 1 is 6, right? Okay, so maybe when you write it for me, then the next step, put F of 6, right? So that G of 1, continue erase it and put 6. So you can put that on your paper if you wish. And now what is F of 6? F of 6 is 5. Is that right? So So you do the inside first. B, G of f of 1. So you do the inside f of 1 first. F of 1 is 3. So maybe on your paper, put down G of f of 1 equals G of 3, because f of 1 is 3. And now I want G of 3. So G of 3 is 2. Right? So that's the answer to B. C, f of 1. Sorry, it's still a little bit heavy. So you do f of 1 and put that back into f. So f of 1 is 3. Put that back into f. So f of 3, 4. Is that okay? Yes, I know some of you put something in the chat, but I can't read it. Or if Prasanna, you can handle it, go ahead. Thank you. In case you're wondering, A and B do not mean the same thing. A lot of times you get different answers. They might be the same, but in general they don't. So in other words, composition of functions is not commutative. Remember, there's something called a commutative property. There's a commutative property of addition and multiplication, right? Not for subtraction, not for division, where the order doesn't matter. Like, 7 times 5 is the same as 5 times 7, right? 7 plus 5 is the same as 5 plus 7, but not subtraction, right? 7 minus 5 is not the same as 5 minus 7. Division is not commutative. 7 divided by 5 is not the same as 5 divided by 7. And composition of functions in general is not the same. So f of g does not have to be the same as g of f. Okay, g of 1. So g of 1 is 6. So maybe on your paper now put G of 6. And what is G of 6? 3. Sorry, I got to put the book down. Got tired. I'll lift it back up when I'm ready. Okay, I think I'm ready. Okay, E, G circle F of 3. G circle F of 3. So I do F of 3 first. F of 3 is 4. So now I'm doing G of 4. So what is G of 4? 1. All right, and then finally F. Sorry, I can't focus it. And F circle G of 6, and that's all I can do. So I do G of 6 first. So G of 6 is 3. So now I'm taking F of 3. So what is F of 3? 4 looks like. Okay. All right, then the last one I was going to do is 53, and then I was going to stop and give you something to do in class. I do see something in the chat, so let me check the chat real quickly. Let's see. All right. So yeah, go ahead and write it. Solve, write the equation, solve after. Yeah, okay, I think we got it. Okay, 53 is the same thing except there's no table. You got to look at the text. But if you look at the text, that's sort of like the table, right? So find these, and it says some of these might be undefined. So why would it be undefined? Okay, so you have a G graph, which is in blue, and the F graph, which is in red. Okay, I can hold it for just a moment if you want to look at the video later, and that's all I'm willing to do because the book gets too heavy. Okay, A, F of G of 2. So we're supposed to do G of 2 first. So G of 2, blue graph. Remember, these are always X, these are inputs. So G of 2 is up here. So where is here? 1, 2, 3, 4, 5. Is that right? So inside, this is 5. So now I want F of 5. So red graph, X is 5. 2, 3, 4, 5. I'm up here. So where's here? Looks like it's 4. So the answer to 53A is 4. Okay, go ahead and write it down. B, G of F of 0. Start with F of 0. So F is the red graph. Red graph, F of 0 is 0. 0, 0. So take that 0 and apply it to G. So X is 0, blue graph. Y looks like it's up here. So where's here? 3. Okay. C, F circle G of 0. That means I do G first. So G of 0 is 3. Right? So G of 0 is 3. And now I do the second function, F. So F of 3, red graph, 3, looks like it's 0. So the answer to C is 0. Sorry, I can't write it. And if we were meeting on campus, I would show this to you, and I have a whiteboard where I can write it, but I can't do it now. Okay, D, G circle F of 6. I do F of 6 first. So F of 6, where's 1, 2, 3, 4? So it's way out here. So it's way up here. So where's here? 1, 2, 3, 4, 5, 6. F of 6 is 6. Take that 6 and apply it to G. So look at the blue graph. Ah, I see what's going on. Look at the blue graph, X equals 6. What do you see for the blue graph, X equals 6? There isn't anything, right? The graph stops at 4. So D would be undefined. Undefined. You could also put does not exist. DNE for does not exist. We'll do that quite a bit in our class. So DNE, if you wish, does not exist. Okay. And then G of G, F of F. G circle G of -2. So we completely forget about the red. Don't even look at the red graph, right? Because we're doing G and then G again. So G of -2. G of -2 is here. So that's 1. Right? And now I apply 1 G to 1. So X is 1, Y is up here. So 4, answer is 4. And finally, F of 4, and then I'm done. F of 4. So forget about, okay, so this blue graph doesn't exist. Just only look at the red graph. F of 4, 1, 2, 3, 4. Let's see, where am I? 1, 2, 3, 4. It's up here, right? So where's here? 2. So F of 4 is 2. Now I do F of 2. So F of 2 is down here. So -2. So the answer is -2. Okay, I got to put the book down. It's tiring, folks. Okay. Okay, folks, I think I'm done. Okay, so I did everything I was going to do for 1.3. So again, on the schedule, I was going to do 1.3 tomorrow. I'm finished today, so it looks like I'm a day ahead. But that's always good in case I fall behind a little bit later. Okay, any other questions? Check, I don't think there's anything else in the chat. Okay, so I'll go straight to the in-class assignment. All right, so again, once you have the answer, you don't have to show your work, just type it out. But you will have to do stuff like x squared, x cubed, and stuff like that. The book is heavy, so if you have the book, then just go with it. Otherwise, I ask you to write it down fast or take a picture on your cell phone so I can put the book down, I guess. Okay, so for right now, 33, I want you to try A and B. So look up there, 33. F of x is 3x plus 5. G of x is x squared plus x. Okay, so part A and part B. F circle G and G circle F. F of G, G of F. If you need help, you can ask Prasanna. Now, you guys you cannot send private chats to each other, all right? But you can send a, chat to me and Prasanna will see it. Okay, so 33, A and B. Find F circle G, G circle F. I told you how to type x squared, x cubed, and all that stuff, all right? So once you have your answer, you may leave. Again, anytime you give answers here, please give it as a private chat, because if you send it publicly, then somebody else can just copy what you have, and I don't want that, of course. I want you to think about it. Okay, I'm going to hold this up just for about 10 more seconds because the book is heavy. So 33, A and B. Take a picture on your cell phone or copy it, or if you have your book, you're good. Just do A and B. I told you how to type exponents like x cubed, x squared, and all that kind of stuff. Okay, and that's about it. I'm going to make this disappear. Okay, so if you have a question, you can ask me or ask Prasanna. I'll stop the share. When you're done, you can send it, and I will see you tomorrow. And I'll stop the recording.